100,000 books. No catalog, no genres, no one to tell you what belongs where. Only the books themselves and everything you could measure about them. This is unsupervised learning, finding the order that was already hiding in the data. Before you sort a single book, you face a quieter question. Each one carries dozens of traits: length, vocabulary, era, complexity, tone, too many to hold in your head at once. So you look for the few master directions along which the books truly differ, and let those axes do the describing. Center the data, then form its covariance, how every trait varies with every other. Its eigenvectors are those master directions. They're eigenvalues, how much variation each one holds. And here's the symmetry at the heart of it. The direction of greatest spread is also the direction of least distortion. Maximize what you keep, minimize what you lose. And it's the very same line. Each eigenvalue, divided by the sum of them all, gives the fraction of total variation that axis captures, so you keep the largest few. Project the books onto them, and 50 tangled traits collapse into 2 or 3 new axes, each a blend of many. One might be overall literary complexity, vocabulary, sentence length, and theme density rolled into a single measure. Another, era and style. A few composite descriptors, where there were 50. Now the grouping begins. The simplest pact: decide how many sections you want, say 10, and plant 10 signs on the floor. Send each book to its nearest sign, then move every sign to the heart of the books that gathered around it. Repeat until nothing moves. K-means minimizes one thing, the total squared distance from each book to its center, its inertia. Assign every point to the nearest mean. Recompute each mean from its members. Iterate, and the sections settle. Every step can only lower that total, so it always converges, but only to a local minimum, which means where you drop the first signs matters. Spread them far apart to start. That's k-means ++, or a careless seeding can settle into a worse answer. And here is its hidden identity. For anyone who knows the name, this is expectation maximization on a mixture of round, equal-size Gaussian blobs, but with every book committed fully to one. A hard assignment rather than a soft one. Clean and fast, yet you chose K, and every book must belong, even the misfits. But why fix the number at all? Walk the shelves instead, and watch where books pile up. Wherever a book sits among enough close neighbors, a section grows outward through the crowd. And the lonely books, adrift in empty space, those you simply leave uncatalogued. Pick a radius epsilon and a minimum crowd. A book with enough neighbors, inside that radius is a core. Cores reach to cores, and clusters grow by connection. A book that isn't a core itself, but falls inside a core's radius, still joins. That's a border. And a book that's neither, reachable by no core at all, is named noise left out, never forced to belong. So every book ends up one of 3: core, border, or noise. Sections take any shape the density draws. The catch: one radius for the whole library. And there's the flaw. A real library has crowded aisles and sparse ones. All at once, no single sense of dense fits them all. So stop choosing one. Look across every level of density. Watch which sections appear and dissolve, and keep only the ones that hold together the longest. Measure each book's distance to its kth, neighbor its core distance, and stretch every pairwise distance by it, so dense and sparse are judged on fair terms. That stretched measure is the mutual reachability. Connect all the books into a minimum, spanning tree on it the cheapest web that links them all. Now raise the density threshold and watch the tree break apart. Discard the splinters too small to count, and what remains is the condensed tree of real clusters. Score each by how long it survives as the threshold climbs its stability, and keep the set with the greatest total. Never a branch and its own parent together. The most persistent sections win, each at whatever density it naturally lives. Same 100,000 books, 4 philosophies, 1 map, 3 libraries. PCA never grouped anything, it redrew the very axes the others sort along. K-means cut 10 tidy sections and wedged the strays in regardless. DBSCAN traced the natural shapes and set the oddities aside, but blurred the aisles that differed in density. HDBSCAN found each subject at its own density and let the truly singular book stay singular. None of them is the right one. Each answers a different question. PCA asks what the meaningful dimensions are and often runs first, clearing the way for the rest. K-means when you know how many groups you want and they are roundish. DBSCAN when shapes are strange, density is even, and outliers matter. HDBSCAN, when density itself varies, and you'd rather not guess a radius. The shape of your data decides, not the algorithm's reputation. 100,000 books, finally at rest, not because someone labeled them, but because the order was always there, waiting to be measured. 4 ways of listening to the same shell.